Now see here, sir. This is a very, very good question. 7 power 7 power 7 divided by 9, and even this is also a good question. What is that we just discussed? A power n plus b power n is always divisible by a power n plus b power n is always divisible by a plus b. A power n plus b power n is always divisible by a plus b if n is an odd number. A power n plus b power n, it is always divisible by a plus b if n is an odd number. This is a CAT exam model question. This is a CAT exam replica question. CAT exam model question. CAT exam model question. If you listen to my classes, all the CAT previous year questions are also a part of it. If you are preparing for an examination like CAT, probably any other aptitude examination will be extremely easy for you. The question is 4 5s power 4 2s plus 4 2s power 4 5s divided by 7. Let me write it. 4 5s. Then I will solve the 15th question. 4 5s power 4 2s plus 4 2s power 4 5s divided by 7. Divided by 7. This is the question. Now see here. How to solve this question? First make this. Divide 4 5s by 7. So these is nothing but 7 7s are 49. Remaining it is 65. 7 9s are 63. 25. 7 3s are 21. Remaining it is 4. 4 power 2 2 2 2 2 2 2. Plus divide this number by this number. 7 3s are 21. 12. 7 1s are 7. 52. 7 7s are 49. Remaining it is 3. 3 power 5 5 5 5 5 divided by 7. First make the numerator base smaller than the denominator. Then make it into 4 square power 1 1 1 1 1. These are nothing but 3 power 5 power 1 1 1 1 1 divided by 7. Divided by 7. Very, very good question, sir. Again, I am repeating here. Please see here. 4 5s divided by 7. 7 7s are 49. 65. 7 9s are 63. 25. 7 3s are 21. Remaining it is 4. 7 3s are 21. 12. 7 1s are 7. 52. 7 7s are 49. 3. 4 power 4 2s plus 3 power 4 5s. 4 square power 4 1 3 power 5. 4 1s it is nothing but an odd number. A power n plus b power n is divisible by a plus b. So it is nothing but 4 square plus 3 power 5. 16 plus 243. This is nothing but 259. 259. It is perfectly divisible by 7. 7 3s are 21. 7 7s are 49. 7 into 37. It is perfectly divisible. First thing, 9 1s are 9. Negative remainder is minus 2. Minus 2 power 7 power 7. Divided by 9. This is an odd number. Minus power odd number, it is an odd number. So it is minus remainder of 2 power 7 power 7 divided by 9. Minus remainder of these minus 2. 9 1s are 9. Negative remainder is minus 2. Negative remainder is minus 2. So minus 2 power odd. So minus came outside. Now you can solve this question very, very easily. So remainder, which power of 2 when divided by 9? The remainder it is 1. 2 power 6 divided by 9 it is 1. So divide this power 7 power 7 divided by 6. 6 1s are 6. Remainder it is nothing but 1. Remainder it is nothing but 1. So 7 power 7 dividend equivalent to divisor into quotient plus remainder, divisor into quotient plus remainder. Don't forget there is a minus outside, minus remainder of 2 power 6k plus 1. 2 power 6k plus 1 divided by 9. So minus remainder of 2 power 6 power k into 2 power 1 divided by 9. These 1. It is minus 2. Don't forget these minus. Answer is nothing but 7. Answer is nothing but 7. Sir, can I do by using positive remainder? Positive remainder also will give you the same answer. 9 ones are 9, minus 2. Minus 2 power 7 power 7. Entire idea is to find out which power of 2 when divided by 9. It is giving you 1. 2 power 6 is 64. 64 divided by 9 is 1. Then divide this power with this power. The best way for you to learn mathematics is to start creating your own questions and understand the logics. This logic already we discussed. A power n plus b power n. It is always divisible by a plus b if n is an odd number. If n is an odd number. If n is an odd number. Let us see the next question. Now, till now, we discussed negative remainder concept. Negative remainder concept. But there is a drawback with negative remainder concept. What is the negative remainder concept? Negative reminders. What is the drawback of negative remainder concept? Why are we discussing Euler's theorem? Drawback of negative remainder. Why we should know Euler theorem or how it helps to solve the questions much more faster time. Drawback of negative remainder theorem. Suppose for example, if the question is 3 power 40 divided by 25. If in the exam 3 power 40 divided by 25 it is asked. According to our negative remainder logic, what is the logic? We have to find out which power of numerator when divided by denominator, either I will get plus 1 or minus 1. Which power of numerator when divided by denominator, either I will get plus 1 or minus 1. 3 square divided by 25, 9. 3 cube divided by 25, 27 by 25, 2. 3 power 4, 81. 81 divided by 25, I am not getting. 3 power 6, 729. 729 divided by 25. We are not getting. We are not able to determine which power of 3 when divided by 25. It is plus 1 or minus 1. So for a lot of problems, till now whatever the problems that we solved, you are able to determine which power of numerator when divided by denominator. It is plus 1 or minus 1. But in a lot of problems you cannot do it. So what is the drawback of negative remainder? If the power of numerator when divided by denominator, if the power of numerator when divided by denominator, is not giving plus 1 or minus 1 in less time, then this negative remainder concept is little ineffective. See these questions. 3 power 40 divided by 25. 3 power 40 divided by 25. You are unable to determine which power of 3 when divided by 25. I will get plus 1 or minus 1. So Euler has proposed a very interesting theorem to find out which power of numerator. Now see here. Now first we will discuss the theorem. I hope you understood the drawback of negative remainder theorem. Negative remainder theorem. Now see here. What is Euler's theorem? Euler's theorem states a power phi of n phi of n in higher algebra by Hall and Nair textbook. They call it as quotient of n. A power phi of n divided by n. It will directly give you 1 when A and P are n are co-prime to each other. What do you mean by co-prime to each other? HCF of the numerator base and the denominator, it should be 1. A power phi of n divided by n, it is nothing but 1. It is when A and n are co-prime to each other. Two numbers are said to be co-prime to each other. Two numbers are said to be co-prime to each other if they got only one factor common, and that one factor it is 1. And the another thing is, n is nothing but a composite number. Euler's theorem is used when the denominator it is a composite number. Euler's theorem is used when the denominator it is a composite number. Then what is phi of n? What is phi of n? Phi of n, when I discuss co-primes, I will tell you its application in divisibility function. First we will write down the function, quotient function. Quotient function means write down the number as a power of prime basis. As a power of prime basis. What are P1, P2, P3? P1, P2, P3. They are all prime numbers. They are all prime numbers. They are all prime numbers. Quotient of n is given by quotient of n is given by 1 minus 1 by P1, 1 minus 1 by P2, 1 minus 1 by P3. Sir, from where we got 1 minus 1 by P1, 1 minus 1 by P2, 1 minus 1 by P3? Whenever I am discussing an co-prime concept, I will discuss in detail. Now today's class, we will just see its application. Quotient Euler's theorem is used. Euler's theorem is used when the denominator it is a composite number. When the denominator it is a composite number. Euler's theorem is used when the denominator it is a composite number. Any composite number can be written as a power of prime numbers. 12 is 2 square into 3. 30 is 2 into 3 into 5. 42 is 2 into 3 into 7. 105 is 3 into 5 into 7. Write the number as a power of prime numbers. 1 minus 1 by P1. Just to give you from where we got 1 minus 1 by P1. How many numbers are not divisible? There is a definition that is attached to quotient function. Because it might be a little bouncer for you. I'll just discuss the application part of it. But I will say the definition of a quotient function. Quotient function is the number of natural numbers less than or equivalent to n and co-prime to n. Number of natural numbers. I will write down the definition here. In case if you want to know more about this one, in standard textbooks, it is called tau of n. Tau is the Greek word. Quotient of n. I will write the definition here. Number of numbers. Number of numbers. Number of numbers less than or equivalent to n and co-prime to n. This is the definition of quotient function. Number of numbers less than or equivalent to n and co-prime to n. Number of numbers less than or equivalent to n and co-prime to n. In case if you want to know more about it, this is available. The concept is available in the book Higher Algebra by Hall and Nair. This is one of the very good books. Students who are preparing for IIT must have referred it. This concept, whatever I am discussing, is taken from this book. Higher Algebra by Hall and Nair. Higher Algebra by Hall and Nair. Problems based on Euler's theorem. Problems based on Euler's theorem. Negative reminder, in not all the cases where the power of numerator when divided by denominator will give you plus 1 minus 1 directly. So we will make use of this Euler theorem to get the answer fast. to get the answer fast. First question. Now, one important key point which you should make a note. First, we will write that Euler's theorem in the box which we are going to use it. Reminder 1, a power phi of n, a power phi of n divided by n, it is nothing but 1 when n is a composite number. When n is a composite number. A power phi of n divided by n, it is nothing but 1 when n is a composite number. Question number 1. Once we do 3 to 4 problems, then the logic will be extremely clear to you. Reminder 1, 5 power 37 is divided by 63. 63, it is a composite number. Write the number as the power of prime numbers. 9 is a composite number. So it is 3 square into 7 power 1. 3 square into 7 power 1. So what is phi of n? Phi of n is nothing but n into 1 minus 1 by p1. 1 minus 1 by p2. 1 minus 1 by p1, 1 minus 1 by p2. There are two prime numbers. N is nothing but 63. 1 minus p1 is nothing but the prime base, 1 by 3. p2 is nothing but the another prime base, 1 by 7. These 63 into 2 by 3 into 6 by 7. 21 3s are 63, 6 6 are 36. Once you got these phi of n, directly you can write reminder a power 5 power phi of n, phi of 63 is 36 divided by 63, it is nothing but 1. Just making use of these Euler's theorem concept, a power phi of n divided by n, it is 1. 5 power 36 divided by 63, it is 1. So what will be the answer? Answer is 5 power 37 can be written as 5 power 36 into 5 power 1 divided by 63. 5 power 36 into 5 power 1 divided by 60. These are nothing but 1. 1 into 5, answer is nothing but 5. First problem, you can also make use of negative remainder concept. 5 cube is 125. 63 2s are 126. By making use of negative remainder, first one you can solve it. But second onwards, it will be little difficult for you. Second onwards, it will be difficult for you. Step number 1. Euler's theorem is applied when the denominator it is a composite number. 63 is 9 into 7, which is 3 square into 7. Phi of n is n into 1 minus 1 by p1, 1 minus 1 by p2. What are p1 and p2 here? p1 and p2 are nothing but the prime numbers. p1 and p2 are nothing but the prime numbers. 63 into 1 minus 1 by 3, 1 minus 1 by 7. So answer is nothing but 36. 5 power 36 divided by 63 is 1. Question is 5 power 37. Another 5 should be there. So answer is 5. I hope the first question it is clear. Once you solve few more problems, then it will be very, very clear to you. First question, I hope it is clear to you. Second one, 2 power 100 divided by 153. 153, Euler's theorem is used when it is a composite number, which is 17 into 9, which is 3 square into 17 power 1. 3 square into 17 power 1. So phi of 153 will be, phi of 153 is 150 n into 1 minus 1 by p, 1 minus 1 by 3, 1 minus 1 by 17. So these are nothing but 153 into 2 by 3 into 16 by 17. 51 3s are 6 16s are 96. 6 16s are 96. So this answer is nothing but, 2 power 96 into 2 power 4 divided by 153. 2 power 4 divided by 153. 2 power 96 divided by 153. It is 1. So answer is 16. If you use a negative remainder concept, finding out which power of 2, when divided by 153, it will be very difficult if you use negative remainder concept. Euler's theorem is introduced to save our time and save the number of steps. First question, I hope it is clear. Second question, I hope this is also clear. Third question. Third one, 3 power 80 divided by 25. Euler's theorem is used when the denominator it is a composite number. 25 it is nothing but 5 square. 25 it is nothing but 5 square. Phi of n is n into 1 minus 1 by 5, 4 by 5. So answer is nothing but 20. What is 20? 20 is the quotient of 25. According to Euler's theorem, directly we will get the answer as 3 power 20 divided by 25, which is nothing but 1. But I want 3 power 80. 3 power 80 is nothing but 3 power 20 power 4 divided by 25. 1 power any number divided by 25. Answer is nothing but 1. Answer is nothing but 1. I hope the idea it is clear. 25 it is 5 square. Phi of 25 is 25 into 1 minus 1 by 5. Directly. Otherwise you have to do which power of 3 when divided by 25 it is plus 1 or minus 1. Answer is 1. Next question. Very, very good question, sir. Find the last 3 digits for 57 power 802. Last 3 digits. First we will write the concept. The last 2 digits of a number. The last 2 digits of a number. Last 2 digits of a number. It is the remainder when you divide a number by 100. This is something which I discussed in previous class. Example 123. The last 2 digits. Of 123. It is nothing but 23. This is the remainder when you divide a number by 100. 123 divided by 100. 100 ones are 100. What is the remainder? 23. Last 2 digits of a number. This is extremely important. Last 2 digits of a number is the remainder when you divide a number by 100. Next one. Last 3 digits of a number. If I want the unit digit of a number, I will divide by 10. If I want the last 2 digits of a number, I will divide it by 100. If I want the last 3 digits of a number, I will divide it by 1000. Please make a note of this. Very, very important key point. If I want the unit digit of a number, I will divide by 10. If I want the last 2 digits of a number, I will divide by 100. If I want the last 3 digits of a number, I will divide it by 1000. Last 2 digits is divide by 100. Last 3 digits is divide by 1000. Once you know this concept, 1000 is a composite number. From there you can find the quotient function and get the answer very quickly. I hope the idea it is clear. Now see here. Question. Last 3 digits of 57 power 802. Last 3 digits is nothing but divide this number by 1000. From there you will get the quotient value 1000, it is a composite number. 1000 is nothing but 8 into 125. 8 into 125. So it is 2 cube into 5 cube. 2 cube into 5 cube. So the quotient of 1000 is nothing but quotient of 1000 is n into 1 minus 1 by p, 1 minus 1 by 5. 10 over. Remaining it is nothing but 400. Remaining it is nothing but 400. So this question is nothing but 57 power 400 power 2 into 57 square into 57 square divided by 1000. 57 power 400 divided by 1000. It is 1. 57 square is 3249. 3249 divided by 1000. 1000 threes are 3000. Answer for this question is 249. Answer for this question is 249. Again, I am repeating it. Last 3 digits we want. If it is last 2 digits, I would have divided it by 100. Because it is last 3 digits, I divided it by 1000. 1000, it is a composite number. 1000, it is a composite number. So 1000 is 8 into 125. 1000 is 8 into 125. Phi of n is n into 1 minus 1 by p, 1 minus 1 by p2. So these are nothing but 400. 400. How many times 400 goes in? 802. 402s are 800. Remaining is 57 square. 57 square is 3249. 3249 divided by 1000. 1000 threes are 3000. Remaining it is 249. This question we did it, and fourth question also we did it. Fourth also we did it. Slowly, slowly, slowly we will increase the level of difficulty. Any doubts are there? We will see it in live chat. Anything other than an academic doubt, probably it's of no use to me.